All right, let's dive into one of the biggest shifts happening in software development right now, serverless computing. Now, this is all about a single promise, freeing you from the never-ending headache of managing infrastructure. The goal? To let you get back to what you actually love doing, building amazing things.
And this quote just hits the nail on the head, doesn't it? The whole point of serverless is to stop wrestling with servers and containers and all that configuration, and to start shipping features that your users are actually going to care about. It's really all about speed and focus.
Okay, so let's break down the real difference here. You've got the old world, right? Where you're manually scaling servers, you're paying for them even when nobody's using them, and you're getting those awful 3 a.m. alerts when something inevitably crashes. And then you have the serverless promise. Automatic scaling, a true pay-as-you-go model, and way higher reliability. It sounds almost too good to be true. So how on earth does it actually work?
First things first, we have to talk about the name, because let's be honest, serverless is kind of a terrible name. The first question pretty much everyone asks is, wait, so there are no servers?
Well, not exactly. The servers are definitely still there, but the difference, and this is the absolute key, is that you don't manage them. Your cloud provider, whether it's AWS, Google Cloud, or Azure, they handle all the provisioning, the patching, the maintenance, all of it. You just get to focus on your code.
I really love this analogy. Think about it. Using traditional servers is like owning your own restaurant. You have to buy the ovens, you have to maintain the plumbing, you got to clean everything yourself before you can even start cooking. Serverless, that's like walking into a 5-star hotel kitchen where all the equipment is pristine, warmed up, and ready to go. You just show up with your recipe, your code, you cook your dish, and you walk away. The hotel staff handles the entire cleanup.
So, if we aren't managing servers, what is actually happening under the hood? Let's peel back the layers a little bit and see how this whole thing is really put together.
Okay, so just follow the flow here for a typical request. Instead of hitting a server that you're managing, a user's request first goes to something called an API gateway. You can think of this as the front door. That gateway then triggers a small, specific piece of code. We call it a function that runs just for that single request. Maybe it grabs some data from a database, does its job, and sends a response back. It's a quick, efficient chain of events.
And this right here, this is the real engine of serverless. Function as a service, or FaaS as you'll hear it called. You stop thinking about your application as one giant program, and you start thinking of it as a collection of these tiny, event-driven functions. One function handles user login. Another one processes an image upload. Each one is totally independent, it can scale on its own, and it only runs when it's actually needed.
But you know, it's not all sunshine and rainbows. This on-demand, pay-for-what-you-use model has a very famous trade-off. And to really understand serverless, we absolutely have to talk about the cold start problem.
So what in the world is a cold start? Well, remember, your code isn't just sitting there running all the time. So when a request comes in after a period of inactivity, the cloud provider literally has to wake everything up. It has to find a machine, spin up a new environment just for your function, and that tiny bit of delay before your code actually runs, that's the cold start.
And you can see that this latency comes from a whole multi-step process. First, the provider has to provision a container. Then it has to load your code and all its libraries. Then it has to initialize the language runtime itself, and only after all of that can your function finally execute. Each little step adds a few milliseconds, and sometimes they can add up.
But here's the good news. You are not helpless here. You actually have a lot of control over these cold start times. The programming language you choose makes a huge difference. So does the size of your function package, how much memory you give it, and even your network configuration. Understanding these levers is the real key to making cold starts a non-issue.
All right, so we've seen the good, we've seen the bad. How does this all translate into a real-world decision? The big question is, when should you actually choose serverless for your next project? It really just boils down to this fundamental trade-off. With serverless, you get automatic management, automatic scaling, and you only pay for what you use. The price for that convenience? You give up some direct, low-level control over the infrastructure. With traditional servers, you've got total control. But guess what? You're on the hook for all the manual work and the upfront costs that come with it.
So, and this is crucial, serverless is not a silver bullet. It's the wrong tool for certain jobs. It's not great for these really long-running processes, like a real-time gaming server that needs to maintain state. If you need absolutely predictable, ultra-low latency, where every single millisecond counts, that potential for a cold start might be a deal breaker.
And honestly, for workloads with constant, predictable high traffic, a good old-fashioned dedicated server might actually end up being cheaper.
But it's pretty clear that serverless is way more than just a trend. It's actively changing how we think about building applications. So where is this all heading? What's next?
We're seeing some really fascinating things happen. Serverless is basically becoming the default choice for AI and IoT applications. There's brand new tech, like micro VMs, that's emerging to nearly eliminate those cold starts we were just talking about. And we're seeing everything move closer to the user, running functions at the edge of the network, which makes applications feel incredibly fast.
And if you need any more proof that this is the real deal, just follow the money. With the market projected to explode to over $22 billion, it is crystal clear that businesses are betting big on this new way of building. This is not a niche technology anymore. It is going mainstream, and it's happening fast. So let's just end on this one thought. We started by busting the myth that serverless means no servers. The real meaning, the thing to take away, is that it means no server work. It's about letting you forget all that heavy lifting of infrastructure. And that leaves us with a really powerful question. What could you build? What amazing problems could you solve if all of that tedious work just disappeared?